Well, based on particle physics, we must have deep comprehensive knowledge about supersymmetry, supersymmetric particles, including fermions and bosons. Actually, supersymmetric particles are hypothetical particles predicted by theory of supersymmetry. However, fermions and bosons are elementary particles of matter in the universe. So, it must be kept in mind that supersymmetry, supersymmetric particles, fermions and bosons are very crucial from conceptual point of view and scientific point of view as well. First of all, let's point out definition of supersymmetry. Actually, supersymmetry is a hypothetical symmetry that combines fermions and bosons into single multiplet, leading to the simplification in the expression for amplitudes in the standard model of particle physics. In other words, supersymmetry is a hypothetical symmetry that proposes a correspondence between fermions and bosons. Moreover, supersymmetry suggests that for every matter in the standard model of particle physics, there exists a superpartner with different spin. This means that for every boson like photon or gluon, there would be a fermion superpartner and vice versa. Here, in case of supersymmetry, fermions and bosons are very common words. So, to get deep concept about supersymmetry, we must be familiar about fermions and bosons as deeply as possible. That's why let's move on to definition of fermions at first. Actually, fermions are elementary particles with half integer spin that follow Pauli exclusion principle, which means no two fermions can occupy the same quantum state simultaneously. Moreover, fermions are also known as fundamental particles of matter, including the particles like proton, electron, neutron, and quarks. Similarly, let's point out bosons. In fact, bosons are elementary particles with integer spin. Moreover, bosons consist of particles like Higgs boson, which are responsible for phenomenon of mass. More clearly, bosons are also known as force carriers or mediators of fundamental forces in nature, including electromagnetism, weak force, and strong force. Here, in case of fermions, half integer stands for integer including 1 by 2, 3 by 2, 5 by 2, and so on. Also, in case of bosons, integer stands for whole number including 0, 1, 2, 3, and so on. Based on supersymmetry, one of the most important master point to keep in mind deeply is supersymmetric particle. So, let's point out definition of supersymmetric particle. Actually, supersymmetric particle is a hypothetical particle predicted by theory of supersymmetry. More clearly, some theories suggest that dark matters are composed of new undiscovered particles such as supersymmetric particles. According to cosmic microwave background, it is clear that supersymmetric particles or dark matters are composed of weakly interacting massive particles. That's why supersymmetric particles are still mysterious. Moreover, if we go on research, in case of supersymmetric particles. It will be clear that if we do something new in case of supersymmetric particles, it might be miracle in case of science and technology. Apart from this, black hole is key concept in astrophysics. So, we must be familiar about black hole as deeply as possible. First of all, let's point out definition of black hole. Actually, a black hole is a region in space where the force of gravity is so strong such that nothing, not even light, can escape from it. More clearly, the force of gravity of black hole is extremely high because in case of black hole, a large amount of mass is compressed into an extremely small volume, resulting in high density. Consequently, this extreme density of black hole causes its gravity to be so strong. Probably, we all are familiar that black hole is invisible. Even though black hole is invisible, we can detect its presence in universe by following the different ways which are given below. Number 1. By observing gravitational lensing of light around the black hole. Number 2. By observing the gravitational effects of black hole on nearby objects such as formation of accretion disks. Also, in case of astrophysics, Blackbody radiation is one of the most important master points to keep in mind deeply. So, let's point out definition of blackbody radiation. In fact, blackbody radiation is defined as the radiation emitted by blackbody which absorbs all the incident radiations regardless of wavelength or temperature and re-emits the absorbed energy at the same rate. Moreover, in case of blackbody, all incident radiations are absorbed due to its molecular structure or atomic structure. Thank you.